HPCC development team, and I hope you've been enjoying the HPCC Systems conference so far. I'd like to introduce Senior Software Consulting Engineer, Shamser Ahmed, who will be presenting today on the Workunit Analysis Tool. We ask that you please hold all your questions until the end of the presentation, and without further delay, it's all yours, Shamser.
Thank you, Kunal. Good afternoon. I'll be talking about the Workunit Analysis Tool. This is the agenda. So I'll begin by talking about why we need to analyze work units. I'll go on to manually analyze work units so you can see some of the processes involved. And then I'll be introducing the Workunit Analysis Tool itself, followed by a demonstration. And I will continue on to introduce some challenges we're facing in implementing the Workunit Analysis Tool. So let me just go on to why we need to analyze work units. Now, once you've written your ECL, you expect it to be as efficient as possible. It's not necessarily the case. The compiler doesn't know about your data. There may be things that you've done in the ECL code that means it's not as efficient as it could be. So there could be redundant activities, inefficient sorting, and various other skew problems. So human guidance is helpful. So examining the graph, you can examine what's going wrong and hopefully make adjustments for that. The other reason you may need to examine graphs is that there may be errors in your ECL. There may be, say, you expect something to take a minute and it's taking an hour. Something's gone wrong, and it could be something you've done in your ECL. Or it could actually be a platform issue. The platform isn't infallible. There could be some things that hasn't been, there could be some issue in the platform, which means that it's not produced the most efficient code. So unless you examine the graph, you don't know what's going wrong. So, you'll examine graphs, and you can identify issues in skews, spills. There may be bottlenecks in external services. And the various operations may not be optimal. So this is why the work units needs to be analyzed. We need to make sure that the platform is doing what you expect, and also to gather information you need to optimize your ECL code and identify any issues. And my view is that an ECL-related project should not be considered complete until it's been fully analyzed. Okay, so I'll begin by giving you a brief, very, very brief manual analysis, just a quick run through for people who've written ECL and not bothered to check the graph. So this is something you should be doing if you haven't been doing it already. So I'll begin by looking at this real-world work unit taken from a development server. I've grayed out some things that may be sensitive. So, but I'm not sure if you can see this. This work unit has taken 1 hour, 17 minutes, and it's running on a 400-way cluster. So this is quite a significant amount of resource. And anything you can do to reduce that would be great. I mean, occupying a 400-way cluster for 1 hour, 17 minutes is expensive. Okay, so to look into what's going wrong, we're going to go into the graphs and delve in there and see what we can gather. So when you go in there, the timers, you'll see that with a large graph, it takes some time for the graph to be obtained. So that's a lot of time, your time that's wasted just waiting for things to happen. So it's fetching data, and in my computer when I was doing this, it was taking a few minutes to do this. So eventually, when the graph comes up, you can see a massive graph. This is actually not a huge one. Some of the ones I've seen is very, very large and complicated, and so it's even harder to work out what's going on. So, but let's begin. We're going to start off by looking at some of the subgraphs. So this is a graph. We're going to break it down into subgraphs to see where the time's going. So we click the subgraph, and we get all the subgraph, and then we sort it by time elapsed. And we see that one of the subgraph has taken 27 minutes. So we're going to dig into that, see what it's doing there. So this is that subgraph, and it's reading from a spill file and distributing that, hash distributing that spill file, and then reading from a normal logic file and distributing that and doing a join. So this has come out much smaller than I expected. So looking at the spill read, it's actually not very significant. It's only taken average of 10 seconds, so we're not too worried about that. The skew is not completely level, but there's a slight skew there. So if we go to the other activity on the right-hand side, this is very fast, average of 1.6 seconds. So, but this has a massive skew, 460%. Okay, so where's all the time gone? We've gone down to look at the distributes. So they've distributed it to actually reduce the skew, and that's reduced it from 460% to 19%. So after distribution, the two sides are joined. And if we have a look at the stats for that, we can see that it's taken 14 minutes maximum execute time. So we want the slowest execution time to see how long the entire activity would take. And you can see it's 14 minutes. But the average execute is 2.4 seconds. And the skew explains why that's the case. Nearly the entire activity is happening on one or two nodes, just a couple of nodes in a 400-way cluster. So if this is, so you can actually see that one node has spilled 34 times, and that's explained the problem. So if this was actually made more efficient, the whole activity could be done in 2.4 seconds. Okay, potentially most efficient. So that 1 hour, 17-minute job could be reduced to, with just fixing this, to less than 1 hour, possibly. Okay, so that's giving you a rough idea of the analyzing process. And we've just touched on the analysis. And if you really want to delve in, there is lots of stats, lots of metrics you can go through. And these are some of them. There's more. And then you've got this big graph to go through. And I can't imagine someone being able to go through all this. Okay, so You know me. All right. So you had a question about whether this could be presented better. Well, we can look into that in a minute, but let me just go on to the actual Workunit Analysis Tool. So I'm going to give you a quick presentation on that, and then you can see how it works, and then maybe it'll answer your question. Okay. So do we analyze work units? I mean, do we? Sometimes, yeah? We have to. What, thoroughly, or just? Okay. I expect that probably not enough. I mean, most people are probably not doing it enough, and probably not to sufficient depth. And I think you'll agree that it's difficult to understand large graphs. I've been doing this for a while, and I struggle. And the number of metrics is sometimes overwhelming. And really, most people don't look at all of, don't look at more than one or two. Okay, and we don't necessarily have the time to analyze every job every time it executes. Has anyone been able to do that? Analyze every job? No one does that. So that's why we need the Workunit Analysis Tool. It is designed to do what you do in analyzing work unit. The process that I went through in manually analyzing the work unit, the Workunit Analysis Tool is designed to do this. So the Workunit Analysis Tool is designed to provide the information for you to improve the performance and diagnose any issues. So you've asked, can it be provided in a better form? This is what is the better form. So the way it works is the Workunit Analysis Tool will examine the graph and the metrics. It breaks up the entire graph into activities. The analysis tool itself can look at the activity itself, look at the edges coming into the activity, look at the edges going out, look at any activity upstream or downstream, whichever is useful. So, those activities are fed into a rules engine, which examines various metrics. So whichever, for example, the distribute skew, it'll look at the skews. And if it's beyond a certain threshold, it will look at what could be causing that and if it's significant. So once it's matched a rule, it'll calculate the cost of that issue. So if the skew is possibly caused a delay of half a second, it might not be important, but if it's caused a delay of half an hour, we want to know about it. So it calculates the cost, and depending on the cost, it lists the cost in cost order, and the highest cost in each activity is reported when it's above a certain threshold, which is configurable. So how's the cost calculated? We determine the cost to be the actual time taken minus the theoretical ideal time. So the theoretical ideal time is, it's difficult to determine, but we've got a rough calculation now, which is made like this. It looks at the average execution time and determines that to be the theoretical ideal. That's good enough for now, and we'll keep improving that. So on a 400-way for, if you have the slowest node taking 45 minutes and the average node taking 10 minutes, then the entire activity time is 45 minutes. Now, if you could spread that load evenly across the entire cluster, then the whole activity should take 10 minutes. So the theoretical ideal is 10 minutes. So we use time as a cost. So we say that if the actual time is 45 minutes and its ideal time is 10 minutes, then the cost of this issue is 35 minutes. Okay. So this is a quick demonstration of the Workunit Analysis Tool. Some code designed to generate SKUs. It doesn't make any sense, but you know, it does something with data and creates lots of SKUs. And so we executed this on through ECL Watch. And as soon as we've executed, the Workunit Analysis tool executes automatically as soon as the Workunit completes, and produces the analysis where you get the compiler and other messages from the job. So the bottom part, you can see the analyzer messages. Significant skew in records causes uneven disk read time. So in this job, there's 4 issues it's found. And that's it. You don't have to do anything. The analyzer is going to execute automatically after your job executes. Okay, so there's not much to learn, really. Now, I'm going to go and give you an example of the command line tool as well. And again, apologies for the writing being quite small. It looked bigger on my laptop. So we're doing this for some of the historic jobs, so where the Workunit hasn't executed because it's from a previous version of HPCC. And when that's, we're going to execute against a job that executed on one of our development servers. And actually, this is the job that we looked at earlier, the one where we found the massive skew causing 15, 16-minute delays. Okay, so we executed it against that job, and within this took less than half a second, and it's come up with all these issues. So when we analyzed it initially, it took us maybe 5 minutes, 10 minutes to get to one issue. In 1 second, the analyzers provided a list of issues you need to look into. So the tool, for your information, if you want to run it against your older jobs, is a command, an option within the WU tool. You give the WU tool, analyze, the DALI server, and the Workunit name. So that will analyze your Workunits. Okay, I mentioned I was going to talk about some of the challenges. Okay, it's not 100% there yet because we have some issues. This is a data set which is an 8 gig file. It's actually sent by Richard Taylor. And in that file, we have a skew of 260%. So we should see some issues thrown up by the analyzer when we execute some queries against this data set. So this is a query against that data set. It does a disk group aggregate, and you can see what is found. Okay, sorry, this is the metrics. We're going to just have a look at the metrics for this activity. You can see that there is massive disk skew, I/O skew. You can see that there's the read skew is quite high, similar to the I/O, but the maximum and minimum execute time is the same. Okay. Now, when we executed this in the analyzer, it didn't show any issues. The reason is the execute time is the same. Just across all the nodes, the execute time is even. Okay. You can see the average. You can see the average execute time as being 43 minutes. So what happened? Did all the nodes execute evenly? Could this be more efficient? Yes, it definitely could be more efficient. What has happened is certain activities, they require the nodes to cooperate. So in this grouped aggregate, you have this situation where the node processes all the data in its own node, and then has to wait for data coming in from the other nodes, so it can complete the aggregate. Now, if all the data, all the nodes need to wait until all the other nodes are complete, then you can't see any skews at the moment. So this is a problem in the, we need to look at what metrics are generated, and we need to fix these before some of the issues are shown. So this is kind of issues that we need to fix as well. So that's the demo, really. I mean, there's not much to the analyzer in terms of what you see, but oh, okay. So it's a tool for developer. It won't tell you if something is right or wrong. You need to look at the information provided still, and decide if any changes are needed. It won't catch every problem, if you have concerns, you need to still analyze the workunit manually. So, it's not a magic tool yet. So we do have some improvements planned. We want to improve the cost calculation. We want to add more rules. We want to make it more configurable. So if it's reporting an issue and you think, it's going to report that skew, it's expected. You can, tailor it. You can configure it so it doesn't report that. We would like to also provide live analysis. So while the job is executing, it could report problems. So after every activity completes, it could report problems. And finally, adding Roxy support. Now, if the analyzer can analyze every work unit, every graph, every metric, and it can do this every time, it should be quite helpful. The work is still in progress, so if you have rules that you can suggest to us, we can add those in. 5 minutes. Sorry, I was rushing the last bit because I thought we were trying to get out of time. Actually, I can go to questions now. So, do you have any questions?
So for work unit fails, will it run on a failed work unit? Because a lot of times it's hard to determine exactly where that work unit failed.
Not at this time, but once we've completed the live analysis, so it executes while the work unit is executing, then it will report the problems. So you'll know straight away.
Yeah, the output from the analysis, it looked like it was just giving the identifiers for the activities.
Yes.
Are there any plans for getting it to report the actual line from the ECL that was for that activity?
What we're planning to do is provide links from the issue to the graph. And from the graph, you should be able to get to the source line.
Okay.
Does that help?
Otherwise, you're going to be sitting there with your list of activities and going through the graph trying to find where this activity is.
It's a good question. We are actually, the ECL watch, the graph viewer, will have the analysis embedded in that. So Gordon is working on that. So he'll take the analysis and provide it in the graph straight away. So you'll see, I don't know how he'll do it, but he might highlight the boxes that you need to dig into.
So how do we get this tool as
It's built in, so it'll run it automatically. You can disable it. It's version 7.6. So, so if you have a local copy, so if you install it locally, you could execute against some 7.0 work units using the Woo tool on the command line.
What is the additional cost that it incurs to an actual work unit when you are running this live along with the work unit?
The largest work unit is going to take a second and a half.
Thank you.
So, the workload is minimal.
Thank you.
It's kind of hard to see all the way from the back, so I apologize. But as far as the outputs that are being created, can we actually get a physical copy of the output that comes from the Workunit Analysis Tool so we can use it for comparisons?
The analysis will be stored with the work units. If you have a look at the messages section, it'll always be there. If you want to extract it, not at the moment. You can run it in command line and have that outputted. So you can redirect from the command line, but it's something we can look into. Yeah. So this, you can execute against any job. Just provide the work unit ID and the daily server, and you have a whole list of issues, and you can redirect it to a file. But if you have better suggestions, just email it. It's a work in progress.
Sort of related to that, is there any way that you could have this alerting on larger issues across work units? So you might find that you have lots of work units where they're not quite ideal, and you get lots of things like this, and you're not going to get everyone look at every work unit, but something in the background that says, okay, this one had a cost of half an hour, tell someone about it, or be able to query that, rather than having to somebody actually look at each work unit, or only pick at ones that they think might potentially be issues.
It's a good point. I understand what you're saying, and I think it's something we could look into. We'll look into, because Gordon has these dashboards, so he could maybe grab work units that has highest cost issues and flag those up to the top. So it's a good suggestion. I'll keep that in mind.
Cool, thank you.
When we come up with suggestions, should we just go into the gyro system and create gyros for you? This way you don't have to remember them?
Yep, that'll be useful. If you can create a Zyra, that'd be good.
Hello, is it meant just for developers, or can we use to spot problems in production, or for my testers, the QC team, to realize that the ECL code submitted today is bad and ask for improvements, or only for developers?
Can you repeat that? So you're asking if this can be for...
Use it to spot problems in production.
Yeah. Once this version is deployed, 7.6, it will be available in production. So it'll execute automatically in production, and it will also be configurable. So you can say, okay, for this job, turn it off. So the information, you can go into production, development, and gather that information.
Okay, thank you.
Okay.
Anybody else?
Okay. All right, thank you. Thank you all.